Hello, this is my presentation on IMAPS and DNS for server system security, CYBR 4220. IMAPS is a protocol designed to securely retrieve emails from a mail server, and unlike PLP3, which we discussed for our last discussion, which downloads emails to a local device, IMAPS allows users to access their emails directly from the server without permanently downloading them. This feature is also useful because it enables users to access their emails from multiple devices seamlessly. Um, any changes made, such as marking an email as read or moving it to a different folder, are synchronized across all devices. This makes IMAPS ideal for users who require constant and flexible stuff across their inbox. To protect email communication, IMAP uses TLS and SSL encryption, and by default, it uses port 993. This ensures that the retrieval of emails remain private and protected from unauthorized interception. Without the encryption, attackers could easily capture login credentials and sensitive email content, which makes implementing secure IMAPS configuration essential for maintaining privacy and data protection. Uh, to configure with IMAPS using Dovecot, first you need to ensure that the software is installed on your Linux system by running the command sudo apt-get install Dovecot IMAPT. And once installed, IMAPS must be enabled by editing the Dovecot configuration file, and you can find that at /etc/dovecot/dovecot.conf. The protocol should be set to include the IMAPS to allow the secure retrieval of emails. Another crucial step after that is to configure the SSL and TLS settings. The configuration file is located at /etc/dovecot/con.d/10.ssl.conf. This you can specify the correct SSL certificate path and ensure encryption is enforced. Once all necessary changes have been made, the Dovecot service should be restarted with sudo systemctl restart Dovecot to apply the new configurations. Once you complete these steps, the IMAP service will be fully functional and ensuring email retrieval through port 993 with encryption enabled. As for hardening tip for IMAPs, securing an IMAP server requires a few things. One thing is to enforce strong SSL and TLS encryption. Outdated encryption protocols should be disabled to prevent vulnerabilities, and instead implement some new modern encryption standards, such as TLS 1.2 or 3. Those should be used to ensure a secure connection. Another hardening tip is to implement access controls. Implementing strong passwords and restricting login attempts can help mitigate brute force attacks. Where possible, multi-factor authentication should be used to add an additional layer of security. Lastly, ensuring that you have regular updates with the Dovecot that ensures that known vulnerabilities are patched and this reduces the risk of exploits and potential cyber attacks. DNS stands for Domain Name System, and it is an essential component of internet infrastructure as it translates domain names into numerical IP addresses. When a user enters a website address, for example, google.com, example.com, YouTube, DNS resolves it to an IP address and it enables communication between the computer and web servers. This process helps simplify to navigate around the internet by allowing users to remember domain names instead of complex numerical addresses. It just makes it easier essentially. Although DNS is pretty valuable in networking, it's also a target for cyber threats such as DNS spoofing, DDoS attacks. These attacks can compromise the integrity and reliability of online communication, and properly securing and configuring these DNS servers is very necessary. So to configure DNS using ISS on Windows, the process starts by opening Server Manager and installing the DNS rule. And once you install that, DNS Manager is used to configure the required DNS zones and records. You can check if the DNS queries are processed correctly by configuring to port 53. The configuration can be verified using PowerShell commands or using the GUI within the ISS Manager. Once all that's complete, the Windows DNS server will be able to handle the domain names and while also allowing admins or users to enforce security policies such as access restrictions and logging. So for hardening tips for DNS on Windows, first, data integrity protection is essential. One way to achieve this is by using something called DNSSEC or Domain Name System Security extensions. This prevents DNS spoofing by authenticating responses and ensuring that they have not been tampered with. Also, restricting access to the DNS server is another key security feature. This could be accomplished using access controls lists or ACLs, transaction signatures or TSIGS. These mechanisms prevent unauthorized modifications to DNS records and to protect against unauthorized access. Another important hardening measure is limiting zone transfers. By restricting zone transfers to only authorized secondary DNS servers, admins can prevent attackers from gathering detailed information about a network's DNS structure, which could be exploited in reconnaissance attacks. Configuring DNS with bind on Linux. On Linux systems, the most widely used DNS server is called Bind, Berkeley Internet Name Domain. To install Bind, admins can use the command sudo apt-get install bind9, and once installed, configuration settings could be modified by editing the name.conf.option file located at /etc/bind/name.conf.options. This file defines important settings such as listening interfaces and port configurations. To create custom DNS zones, the name.conf.local file is used to define zone entries and their records. Once the necessary configurations have been made, the bind service has to be restarted using sudo systemctl start bind9. And once you complete these steps, the Linux DNS server should be ready to use those domain names correctly. As for hardening tips for DNS on bind, one of the first things you could do is to disable recursion if necessary. Recursion should only be enabled on trusted networks to prevent unauthorized users from using the server for DNS lookups, which can lead to DNS attacks. Zone transfers should also be restricted to authorized secondary DNS servers, as these unauthorized zone transfers can expose critical DNS records and provide attackers with valuable information about an organization's infrastructure. Lastly, limiting query access is very crucial. By ensuring that only trusted networks can query the DNS servers, admins can reduce the risk of external threats that are attempting to exploit the system. You can enable DNSSEC as it provides an additional layer of protection by ensuring DNS responses are signed, and authenticated, and this will help prevent manipulation and spoofing attacks. So to conclude, IMAPS and DNS are two pieces of technology that play a major role in securing email communication and internet navigation. Um, proper configuration is proper configuration is essential to prevent cyber threats such as DNS spoofing, man-in-the-middle attacks, unauthorized access, and yeah. For IMAPS, implementing strong SSL and TLS encryption, enforcing access controls, and regularly updating software are key security features. As for DNS, securing DNS, it requires the use of DNSSEC, restricting access to trusted users, disabling recursion when unnecessary, and monitoring server activity for anomalies. Um, using these practices, organizations can maintain a secure and reliable network infrastructure, um, and protect against potential cyber threats.